All right. Well, we got another build today, and this is actually a redesign of a project that I developed called MIDI Mixer. And what it is it's a PCB project that allows you to mix a variety of beats, melodies, bass lines, all that kind of stuff, all controlled through the MIDI protocol. So this was the very first one that I made. So you can see it's got a kind of all wood enclosure, a couple of linear potentiometers, rotary potentiometers, and then these elastomer buttons. Kind of a bit big, runs off of a Arduino Mega, just to handle all of the button presses and stuff for that. But that evolved over time into something a little bit smaller. So this is one that I did this year. So you can see fewer buttons and fewer potentiometers. But as I've iterated on this, I've noticed that there's some significant issues that I'm going to try to address today with the new design. And the first is actually these USB cables. So I have not had great luck with them not ripping out. So I had a lot of students last go around actually just rip the USB connector right off of their board, and that destroyed the microcontroller. So we're going to actually use the ESP32 with our build today, and that's because it supports Bluetooth MIDI communication. So that'll actually make the entire thing wireless, which is great. Another issue that we had was these elastomer buttons. So they have a NeoPixel underneath them, and so they actually don't compress down very well. And because of that, it's actually hard to kind of get consistent button presses. So I'm going to change up the button technology to hopefully improve on that. And then the last issue that I'm addressing is these potentiometers. So the idea is like you're controlling a variety of instruments, with the buttons and everything, and the values of potentiometers. But you have much more functions that you need than there are physical buttons. And so usually what we'll do is we'll make one of the buttons kind of cycle through various kind of modes. And for the buttons, that's okay because you can kind of dynamically remap the function of each button just based on what mode it is. The problem with the potentiometer, right? So like, let's say in this first mode, it controls your drums and you've got the volume all the way up. And then you go to the next mode and maybe it's your keyboard. Well, because this value is set absolutely, it's going to make the volume of your keyboard all the way up. So you're like, oh no, that's too loud, I turn it down. And then when you go back to your drums, it'll read this value again, and then your drums are down. So these kind of hard encoded potentiometers aren't great for that, because it's always just reading a value that exists in the real world. And so I'm going to swap these out with potentiometers. Rotary encoders. These are potentiometers. I'm going to swap them out with rotary encoders, which have the same functionality, but you can actually kind of spin them infinitely. There's no hard stops, and you can save their values in software, so you'll be able to swap through modes and actually remember what those previous modes were. That will mean that we have to get rid of the linear potentiometer, but I'm kind of okay with that. And also, we're going to get some better panel-mounted connections to make sure that it stands up straight, because this one, they kind of get wonky. So to address that, like I said, ESP32, we've got rotary encoders, which are these guys. Again, you can just kind of spin them forever. And then for the buttons, I actually was kind of inspired by what I think is called a MIDI fighter. And so, yeah, so these MIDI fighters actually use, cleverly enough, arcade buttons. And so these are pretty cool. I like them a lot. I've got these that I'm going to be using. So they're just simple arcade buttons that I found on Amazon. I'm going to be trying to source some that have kind of the clear enclosure around them, like you see in here. I really like that because it lets the light glow through a little bit better. I've not been able to source those, so I might be kind of looking at that tonight and seeing if I can figure out where to get those. Yeah, that's kind of the idea. So we'll be including some NeoPixels as well. We've got a whole laundry list of things that we're going to do. So kind of while I'm thinking about it, I'm going to kind of take a look over here and see. Building your own mini fighter, yeah. So this is, I'm trying to find a good source for for those buttons. Yeah, so I've seen these Solana. So yeah, so they're using yeah, these translucent push buttons that have LEDs in them. At least I think they do. Maybe not. But yeah, $4 a piece is kind of steep, and I try to keep things relatively cheap for my my students. So I may not be able to do something like that. These Amazon buttons, you know, I think I get 6 for $10, so little cheaper, but yeah. So we'll see how all this plays out. One of the things that we're gonna have to do today, though, is you can't get those push buttons on LCSE, so we're going to be part sourcing. So I'm also going to be showing y'all today how to actually build your own part in LCSE. So let's go ahead and get started. So we're going to start a new project, and we're going to call it MIDI Mixer. And this is going to actually be probably version, I guess we'll call that 2, just to kind of delineate it from the previous ones that I've created. So we'll call this MIDI Mixer V2. Okay, turn that music down just a hair. I've been getting like copyright claimed on my streaming music, which maybe makes sense. So I'm trying to turn it down. So if you're watching this on YouTube, I apologize if sometimes it goes mute. That's them taking out their out those music samples. Okay, so yeah, we're gonna look at kind of my little kind of shopping list. So yeah, we're gonna do this custom push button, rotary encoders, XLRs. I forgot. So I'm also going to have this be able to control any DMX controlled lighting. So for example, I've got this little kind of servo spotlight that can do a lot of different things. So we're going to be adding that functionality to the MIDI mixer as well. So you can not only control the sounds, but you can control the lights, fog machines, all that kind of stuff. So this is why I keep a list. Yeah, footprint's going to be about 120 by 150 millimeters. That will go over the 100 by 100 millimeter limit. For kind of the cheap boards on JLC PCB, it'll be about $11 for the board, but that's fine. Need to make sure I've got mounting holes because we're going to be doing a white acrylic enclosure for it, which I think will be pretty cool. We're going to do some rounded corners, maybe. That may be tricky with the acrylic enclosure, but we'll probably do the PCB, and if we figure something out to do with the enclosure, then awesome. And then, we're going to be using these mini WS2812s. So they're mini NeoPixels. They're actually 2 millimeters by 2 millimeters, which is very small, which is good because we're going to be actually slotting some of them underneath the buttons. Yeah, and with the rotary enclosures, I'm going to do a thing where like actually make the LEDs go around the rotary encoders, and that's for the purpose of being able to, like, as you turn it, will go like do in lights to kind of let you see what the values of that are. So let's go shopping. So again, we're going to pull in a lot of the stuff that we've done in previous ones. So we're going to kind of go over and visit our MIDI macro. Just again, bring in a lot of the infrastructure about, again, kind of power management. And so, yeah, we're going to kind of pretty much just bring everything over here and kind of like we've done before, just delete anything that we don't want to keep. So let's grab this over here. Should have grabbed that box. There we go. All right, and we'll grab our ESP32 hardware and battery monitor. Okay, I have a feeling like this is going to be a very, very big circuit with everything that we've got going on. Okay, so the one thing that we want to kind of check out, I'm going to double check with the MIDI macro. And like I have a feeling like we're going to be using a different battery for this one, just given how much power it's going to take with all the LEDs and stuff. I don't think these little coin cells are actually going to kind of be the right thing to choose. Now, given how this lays out, I mean, we might leave that in there and just kind of mount in a, some sort of connector for a battery. Yeah, so we'll see. And it's possible that we'll also just still kind of power this thing over USB. But like I said, I'm trying to really avoid the necessity of plugging this in so much because of just the fact that we've had so many issues with it tearing out the USB connectors on them. But again, that was because we were kind of cheaping out on our microcontrollers. That was running off of like a Pro Micro. So anyways, so looking at this, I think we'll probably largely leave this the same. We'll kind of still have our battery monitor doing its thing. I'm going to see if I can kind of shrink this down because I do have the feeling like we're going to need some more room for the rest of our circuit. So I'm going to kind of just shrink this guy down just a bit. And see if I can kind of tuck it here in this corner neatly, like such. Now I do have these 9 buttons, and that's actually kind of good because I am going to be using buttons. Then I'm also going to need these like 3 rotary encoders, so I'm going to kind of delete this for now. So these boot and enable buttons are going to be the same. So I'm actually going to ditch buttons 7, 8, and 9. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, because I'll only have 6 of these buttons. So I'm going to ditch 9, 7, and 8. And we're going to be doing 3 rotary encoders a little bit later on. One of the big things that I'm actually kind of already concerned about is if we're going to actually be able to sustain kind of that many wires. So I think in total we need 2 wires for a rotary encoder, so we're going to need to find 4 open pin, or 6 open pins total for all the rotary encoders. So we'll see. We'll kind of cross that bridge when we get to it. Okay, but I do need to change over. So these buttons are not the buttons that we want to use. So we're going to kind of make a change to that. And that's what I guess we're gonna start with is actually designing this new part. So I'm going to go ahead and save this up. We're going to go up to File, New, and we're going to start off with just a symbol. And so for our symbol, we'll have that there. Maybe something like that there. And I like the way that they do these symbols where there's kind of like a line here. And I've actually not done something like this before. So we'll see how that works. And then how to actually on that button. Okay, so it's just a line with the thing going up through the center. Cool, I like that. I don't like that spacing though. So let's do that. Bring that a little bit closer there. Do they overlap? I'm just trying to make it look like a standard button. Oh, you got the little holes there at the end. Cool. Okay, so those are the, so actually we're going to flip that around. Nope, I want. Maybe that's fine. No problem. All right, we'll see. Yeah, and we'll update this if that is not the right way to do that. Okay. And so I'm going to save this up. And I'm going to call this 30 millimeter arcade button. And actually, we can go ahead and link that, which is kind of nice. So, cool. Link. And this is UX cell. So, UX cell. I don't know if they have like an SKU on these. Let's have a look-see. Part number. Sure. Supplier part number. Supplier. Yeah, others. So I guess supplier is probably Amazon. Manufacturer part number. That I don't know. Yeah, I'm not sure what all these kind of various codes are. But we're going to call that good enough. So we're going to call this a... Yeah, no, that's fine. Okay. So, we'll save that up. Okay. And then, I'm just going to test this out real quick while I have it actually here. I just want to see that those things are done correctly. So if I want to wire something, yeah, so those wires go to the inside, right? Which is the exact opposite of this. So I'm going to figure out how to change that. So presumably you would do something like this, but that's like really weird. Like, because I want that to be there. Orientation 180 degrees. Track this down here. I think I would have done this before. Can we do -20 to make it go the other way? Huh, I cannot. Oh, I guess I can do that. So I could make it 0. Dot clock. Let's do yes. Yeah, see, that's what I want. Okay, so maybe that's how you do it? Okay. So let's do that. Dot. Yes. Okay. This is looking better. So we're going to kind of bring these in just a little bit. Spice number. Can I make that small? I sure can. Alright, just trying to simplify this up a little bit. Cool. So I think I like that a little bit better. That being said, actually, I'm gonna rewrite these so that cool. I like that now. All right, so that's the easy part. So hard part now is let's do a new footprint. And yeah, for this I actually did a little bit of work at the beginning. I'm going to show you what I did. So I was looking at kind of what these buttons look like on the bottom. So you can kind of see we've got these kind of two moderately offset, it's really weird, connectors. They're not perfectly in line. I don't know if that's just to kind of get the orientation right or what. But you need to get a footprint so you can actually kind of solder these into a board. And I went through tons of iterations just designing these in Inkscape, just to try to get the precise kind of fitment of where all these little kind of holes and circles need to be. And I think I finally figured it out. And so I'm going to kind of bring up my little Inkscape design here and work off of that to kind of help me create this footprint to make sure it's kind of as close to the real thing as possible. So the first thing we're going to do is we're going to create a 30 by 30 circle. So we're going to be working on the top silk layer here. And I'll do this. I'm going to change my snap size to 15 and grid size to 10. And so I should be able to, create that. Yeah, so 0, 0, radius 15. Cool. Okay, then I'm going to change my snap size to 12 because I think that's the inner circle is 24 millimeters according to my kind of previous measurements, and I just measured it out with a set of calipers, so hopefully going to be moderately accurate. This interior block is 16 by 13. So I'm going to kind of come over here, and we're going to come out. Does it not tell me a net length on that? It did not. Okay, we know that's 10. That's 5, so that's 16. Okay, that's 10. 1, 2, 3, 13. Okay, cool. And we need to get this kind of centered in here. That should be pretty easy just to kind of eyeball. Odd numbers means we need to get a snap size of 0.5 so we can actually get it perfectly centered. Yep, there it is. Okay, and the reason why this is going to be helpful is we're going to be putting some LEDs in these voids here, and we just need to kind of have a good sense as to kind of where the appropriate placement for that will be. Next thing we need to do is we need to actually kind of create the paths for this to kind of go through. I'm going to kind of put out some guidelines first, and so those guidelines, I'm just going to draw a rectangle here. Actually, in retrospect, I could have done it over there. But anyways, and we're going to make them kind of 3 by 1. We need to make sure that we get these kind of precisely in the right place. So according to my thing, that's negative 4.69 as the x. Negative 4.69, and that does seem right. And then 5.806. 5.806. Okay, good. And then we have another one. And again, these are just going to be kind of guidelines for where these need to go. This is going to be 2.310. And the height on that is 4.806. Yeah, and you can kind of see how they're just slightly offset. That's kind of weird. But guidelines. All right, and then what we're going to do is we're going to come to the top layer, and we're actually going to insert a pad. And if you take a look at these buttons, let me grab another one. Whatever I did with it. I'm just losing everything. Let's see it out. Here we go. Yeah, they're kind of these like flat little pads. And so they're about 3 millimeters by 1 millimeter, just like I have kind of outlined here. And so for these, they're rectangular, so we're going to change that over to a rectangle. And the whole shape is going to be a slot. And for that diameter, we're going to make it 1 millimeter by 3 millimeters, which means that the width of this needs to be about 4 millimeters. And the height needs to be about 2. And I'm going to kind of bump up a little bit. The 1 is actually plenty big. But I'm going to kind of do about 3.5 maybe, 3.25. I'm going to double check because I do want a little bit of wiggle room just in case, you know, the positioning is not perfectly accurate. So let me see how close I am with this. Yeah, so I'm actually going to do like 3.5. with these, just to give myself kind of, you know, some space to kind of work with. Okay, and now what I can do is I can zoom in over here and get these kind of perfectly placed on top of those grid lines. So let's go for 0.1. I can kind of just barely see my silk screen underneath it to get it nice and centered. Okay, and this one is going to be number 2. Okay, and now I should be able to get rid of these grid lines. So if I turn off multi-layer and a couple of these guys, I'm just going to delete these because I don't need these guides anymore. Okay. So, and then we need a 3D model. And so for that, I actually went to a website called GrabCAD because I'm big about having 3D models of all of my parts. And so I did a 30 millimeter, I think I looked for arcade. Oh, here we go, yeah. And so it turns out that this is the exact button that I have. The only small difference is that they have their 2 contacts in line. So the 3D model is going to be a little off in that respect, but for more, this is more about the enclosure design. And so the fact that the enclosure is like spot on is really good. So we're going to be using this, and so I'm going to show you how to import that. And so we're going to actually kind of hang here for just a second. We're going to go to New 3D Model. We're going to add File, and I'm going to go to. Oh, I need to go grab the latest file, which I have over on this computer. So let me transfer it over so I can show you guys how that works. And I worked with this a little bit. It turns out I had to modify it in Fusion 360 just a little bit because I have my Fusion set up to natively have the Z-axis up. In Easy EDA, they natively want the Y-axis up. So I had to kind of change things around to make sure that the right axis was up. But if we come over here, now we can upload it. You can see I've got an arcade button here. So we'll save that. And now it says it's been imported. And so now I come over here to 3D Model. And if I look for 30 millimeter, I should have that here now where I can import it. And I do have to make some kind of small changes. You can see it's way the wrong size. And I need to rotate it a little bit. So if I rotate it 90, yep, how about negative 90? Better. And then if I make, and I can kind of use this as a guideline, I can do 30 millimeters for my width, and we can go a little bit more. That's a little bit too much. 32.5. Yeah, so that looks to be kind of right on the money. And I should begin, if I get it close, I should begin to see kind of this pad at least lining up perfectly. So I'm going to bring it down 6 millimeters so that it's just right above the edge there. And again, there's a little bit of a misalignment there, but I don't think that's actually going to affect things too much. But there's my button. You may notice that I also changed the color of it from blue over wherever I had that to white to match my thing. Okay, so I should be able to update the 3D model. Yeah, and now that's here. And now I can save this, and I'm going to call this 30 millimeter arcade. I'm going to save that out. And now if I come over here, I can say, great, let's go find the footprint. I'm going to look for 30mm. There it is. Match pin 1 to pin 1, pin 2 to pin 2. Update footprint. And save. And I should be able to close these down now. And now what I can do is I should be able to throw in a 30mm arcade button. So I'm going to research for this just to make sure I get the right one. Okay, so here's my circuit. Oh, fascinating. That does not seem to be connecting the way that I had hoped it would. Ah, there it goes. Okay. Interesting. Okay, that's connected now. Just got to make sure that it's done properly. So, how interesting. It just doesn't look like it's automatically grabbing onto those. So we'll just reroute those. Oh, look like that one. Okay, so I'm going to come drop those in just a second. Ditch you now. Okay, so I'm just going to pull these out just to make sure that my VCCs are connected. Good. And then make sure that these are connected. Cool. Okay, there are my 6 arcade buttons. All right, now I've got my buttons, so that part is done. For rotary encoders, I looked at a lot of different rotary encoders. Ultimately, I kind of decided on this one, both for availability as well as kind of it's got a 3D footprint, and it's kind of short. I don't want it to stick up too much because I'd really like to kind of be sensitive about the overall height that it's going to be on the board, because I don't want it to stick up too far because of it's going to like just stick out from the arcade buttons. So we're going to try these out. And so let's drop these in. And like I said, I'm going to need 3 of these. Now these are a 3-button design, 3-pin design. So I'm actually going to have to look to see how to hook these up. I haven't used these kind before for anything. I usually use the ones that come like already like on a little breakout board. So we may need to look at some information to figure out how they are, because I've got ground plus DT and CLK. And it could be that that's, you know, like the ground is because it's got, you know, sometimes these have like push buttons on them. This one doesn't. So let's look at the information here and see if they've got like a pin out. They don't have a pin out. At least not that I can see. Let's go back and look. I'm not sure. I haven't translated much of this. ACB, so I'm just not sure what that actually entails. Okay, so maybe something like this. there's an A signal, a B signal. Yeah, let me see. I've actually got. Do I have some raw ones? Okay, I do. So I've got. This is actually an opportunity to test. Thankfully, I have some of these. So let's pull up Yield Arduino. And I have a sketch that is running right now that should, yeah, do this. Okay. And so I'm going to experiment with the one that I have and make some guesses about what we're doing. So ground or power. I'm going to say probably ground. Okay, I don't need the switch or power. So I'm going to yoink that and that. I'm going to try this just straight up as is. Type if these stayed in the breadboard. Okay, that is not working. Might need to solder these to pins. That's not doing anything. So first thing I'm going to try is swapping that to PCC. Oh, okay, cool. Okay, so it looks like I do have schematic. Okay, so the way that I have this is I have it oriented with that, and I've got first pin is going to be power. Second pin is going to be DT. So I'm going to make myself a little note here. Always the fun thing. So okay, so we have VCC, then DT, then CLK. Cool. And what I haven't tested, and probably need to test it. Can you run more than one of these at this? Excuse me, at the same time. Let's actually look here. So let's do open recent. Yeah, because I'm using this ESP32 rotary encoder basics sketch. And I've got multiple of these. What am I trying to do? I don't want to run into an issue like I did last time where I build something that just can't work. So any microcontroller input pin with interrupt. Okay. So as long as they have interrupts, I should be okay. Okay. I should be able to do multiples. We'll double check. I think they have one where it's like multiples. Examples, ESP32. Rotary encoder, ESP32. Where? Oh, there you go. Multi-select? Don't know what that is. We'll see. Okay, well, I think we're just going to try it. So let's do this real quick. We're going to deviate a little bit, and we're just going to open recent rotary encoder basics. And I'm just going to hook up two of these rotary encoders real quick, and just actually probably 3, and just double check to make sure that we can run 3 at the same time. Otherwise, this project's not going to work. I'll be right back. Okay, I'm back. Alright, so I brought some rotary encoders with me. And we're going to see if we can get these guys up and running. Hopefully these see a little bit better than the other ones I was testing out. Man, these are just not the stoutest of pins. Do it like this. Cool. There. Let's make sure that actually works. Seems okay. Okay. Let's add rotary encoder number 2. And rotary encoder number 3. Great. All right, let's put up this mess. Then I'll change this. So I don't have a camera set up on my desktop, so you can't see what I'm working on. That's not terribly interesting anyway. There we go. And rotary encoder number 3. Okay. And I'm going to do something kind of stupid, but it's just to test. I'm actually going to plug these into the same pins as the first rotary encoder, just to make sure that the rotary encoders are actually working. Okay. Cool. All right. Now, what I'm going to do is I'm going to pick a different set of pins to plug this one into and see if we can get it to work. So, let's go to the handy pinout reference, and I want to say interrupts. All GPIOs can be configured as interrupts. Great. So that's what I needed to know. So now we just need to pick ones that are available. Alright, so let's have a look-see over here. So we stopped at, let's see, 18, 17, 18, 19, 19. So if I chose 21 and 22, 21's there, 22's there. Do I have, well, we'll start kind of with this block here. So 16. 16 taken up by anything? No. Okay, I'm going to keep a list. So, rotary encoder 1, we'll go with 16. And then is 17 available? 17's taken. So we'll do 18. Taken. 19 is available. Okay, rotary encoder 2. Okay, let's look at 21. Taken. 22. Taken. 23 is open. So 23. And then 25. There's 25. 25 is taken. 26 is taken. 27 is open. Good. Okay, rotary encoder number 3. 32, 33. 32, 33. So 32 and 33 are both open. So 32, 33. And then our NeoPixel, we need to find a good pin for that. So 13 is 13 available. Yeah, so that's going to be pin 13. Okay, and I'm going to kind of just quickly map. Okay. Okay, so let's map this out. Alright, so we're going to go these guys over here. And we're going to go hunting for pins. So first set I'm looking for are 16 and 17. Which unfortunately do not appear to be exposed on this ESP32 that I've got. Let's have a look-see. So ESP32 pin out. Let's see if I can find one that I've got. They could be there, it's just sometimes it's tricky to find them. So mine, one that's oriented down. Yeah, gross. Okay. Ground. Bin. Ground. 3v3. D23 and enable. Okay. That looks like one that I've got. So, we're looking for, 16 and 17. Ah, that's because they're the RXTX 2. Oh. Okay. No. I've got to be careful about this. Because I also know that when we do the DMX stuff, Ooh, smiley face pancake waved. Hi, smiley face pancake. I'm glad you're joining us. I am really good. So, I'm glad you're joining us. So, we're working through a particularly interesting issue with this build. I'm hoping that we'll resolve it pretty quickly and be able to move on. Very good. Okay, I do have this here. Digital design configuration, right? DMX. Yes. Okay. Turns out all the code was on my other one. So what brings you out tonight, smiley face pancake? Test device. Initialize. Yes. So 16, 17, and 21 are off limits. So 16, 17, and 21. So our DMX is going to use 16, 17, and 21, which means we have some changes to make. What brings me out is curiosity. Ooh, what is a PCB? That is a great question. So a PCB is a printed circuit board. So I'm going to kind of show you what that sort of looks like. So we're making some really fun electronics tonight. What I'm making is an improvement on this little guy. This is called a MIDI mixer. And what it lets you do is actually make music from your computer. And so you can load up different sounds and beats and melodies and bass lines. And this plugs into your computer via USB. The one that I'm making tonight is Bluetooth enabled. And it'll light up and you can kind of push buttons on it and trigger different sounds at different times. So it's like lets you be your own DJ on the fly. The PCB is the actual circuit board that has all the electronics. And so I'm designing that tonight and making some real improvements. And kind of show you one of the previous ones that I did before. This was a keyboard that lets you kind of make some quick commands. And so here you can see all the tiny little electronics on it. These are the little keyboard keys that you can press. And I'm using something called an ESP32, which is a tiny little computer that lets you actually interface with your computer. So this is like your own little wireless keyboard, but you can customize it to have any controls that you want. So the thing that I'm working on tonight, these are all the little components, is going to let you make any kind of music that you want. So the nature of this build is it's usually kind of fairly zen. I kind of talk through my process, and yeah, it's here for people to kind of see how electronics are made. I do this because I'm a professor at a college, and I make these kinds of projects for my students to learn about and to build on their own. So yeah, so the new MIDI mixer that I'm making has these really cool arcade buttons for pushing to trigger the sounds. And I'm using something called a rotary encoder, which is like a knob where you can kind of spin and turn it around. And what I'm working on at the moment is I can make these, I can make it so that I can get one to work. I'm trying to get it to where I can get two and then hopefully three to work. But I've got to figure out on this little, computer that I'm programming what little connections I can make. So, yeah. So, I think it's cool too. So, yeah, so I teach a program where my students invent new technologies to try to solve really interesting problems. And problems can be lots of different things. So it could be, people keep getting in accidents in their cars because they're distracted, from cell phones. So how could we fix that? Problems could also be like, I like to make music, and sometimes, making music on a keyboard and mouse is really tricky, so we can invent new technologies like the MIDI mixer to make it even easier to build those technologies. So I've been working on this for about an hour. Most of my builds take about 3-4 hours to make, so you're certainly welcome to stick around as long as you want. And if you've got general questions, I'm happy to kind of answer those, or if you've got things that you want to chat about, that's cool. And if you just want to kind of chill and watch this process unfold, you're certainly welcome to do that as well. And so, a couple of different things that I know I'm going to have to do already. So I just found out that some of these pins kind of are off limits. And so I know that I need 16, 17, and 21. You can kind of see that down here on my little list here. Those have to be free, so I need to make sure 16, 17, and then we're looking for 21. So these are off limits, so I got to kind of figure out another place to stash those. And so I'm kind of using this list to kind of figure out what I can use. So I can use 4. So I'm going to kind of do so I've got B1, B2, B3, B4, B5, and B6. And these are referring to buttons. And so I'm going to kind of go here. And so pin 4. I've got nothing on pin 4 at the moment. That's a sensor. Oh, no, I need to find IO4. Cool. Okay. So that's going to be pin 4. A lot of this is like connect the dots, honestly. But it's a lot of fun. All right. B2, okay, is also not connected to anything, so we're going to scroll down here. Okay. And so we're going to make that on pin 13, which is going to take that away from that one. B3, I think already has one. That's on 26. Yeah, I'm just going to sort of, yeah, just assign that to a different one. So we're going to say that one's going to be on 16. Nope. That one's going to be on, so 16, 17 is taken up. So 18 is available. B4 is going to be on pin 19. B5 is going to be on pin 21. B6 will be on pin 22. And DMX, that's 16, 17. I can't have 21 there. So 22, 23. I'm learning. Yeah, so one of the interesting things about this type of work is you always make lots of mistakes, and that's okay. So making mistakes is part of the process. You just try to catch them before they get too crazy. Okay, so 22, 23. Is 24 one that I can use? No. 25 and 26 can be. 27 and 32 can be used. So these say input only, which means they might be good for buttons, but nothing else. Let me see if I even see these guys on here, because I sort of don't even see them. I may be running out of pins here. This is why we check. Okay. So I have these where it outputs PWM signal at boot, connected to onboard LED. So I'm going to make that one 2. I need 2 more pins. 32. So 33 I can use. Yellow, okay. Output. Boot fail if pulled high. I don't want to use that. 4. 5. Okay, so I think what I'm going to do here. Ooh, so what got you into technology and teaching what you've learned? That is a lovely question. So I've always been the person that likes to tear stuff apart and invent new things with it. So when I was a kid, my parents would give me like old VCRs and TVs and stuff, and I would take them apart and try to figure out how they worked and invent new things. One of my dad's friends worked at NASA, and he'd always bring home just boxes of stuff from satellites they were building and rockets and stuff. And yeah, and that let me kind of experiment with technology as a kid. And so I always wanted just to invent new things. And so when I kind of got into teaching, because I really like to help people understand and explain things, I helped create a new program called Creative Technologies. It's like engineering and computer science and industrial design kind of all together. And yeah, I started a program at a college and have lots of students who are in it. I have a big lab where I have laser cutters and 3D printers and welders and electronics and soldering irons and stuff like that. And so we're on the summer right now. And so during the summer, I spend a lot of time kind of getting prepared for the next semester's worth of classes that I'm teaching. And this summer, I'm redesigning one of the classes that I teach called Advanced Prototyping. And I've got 4 brand new projects that my students are going to get to make. This is one of them. One of the other ones that I'm doing is a smartwatch. And so it will just pretty much function like an Apple Watch, but my students are building it and making the circuit board, the PCB, that printed circuit board by themselves. They're programming it by themselves, soldering it all together. We're also going to be doing like a custom video game controller that they'll build themselves. So to teach them about ergonomics and user interfaces. And so it'll work with, like Mac or PC, Android or iPhone. Haven't quite figured out how to make it work with like gaming consoles yet. So we'll see how that works. But yeah, for me, one of the coolest things is getting to invent new technology, but also to help people learn how to make new technology. So, but I'm a bit of a night owl, so it's midnight where I'm at. So I usually do a lot of stuff late at night, and I figure I'm doing it anyway. So I stream it if people want to kind of see it live. If not, I also record it and put it on my YouTube channel. So they can watch it, so they can kind of learn how to build. And I'll probably try to use some of these videos in my classes for students to be able to follow along. And then I also have a Discord channel where people want to kind of talk or discuss about, different projects, or if they want suggestions, or, kind of like, hey, it'd be cool if you made XYZ. Then I've got a Discord server for that kind of stuff too. So yeah, so that's kind of where I'm at with all this stuff. Let me change that to 5. I'm going to change this to 4 and 33. So smiley face, do you have any interest in technology? Have you worked on anything kind of fun before, or made your own thing before? I always like to ask my students kind of like, what have you made? Even if it's like, I make pancakes and stuff like that. That's really cool. I just like people who make stuff. GXRX. That's probably fine. So, yeah, I always ask people, like, what kind of stuff do you like to make? You've done soldering before. First experience with a soldering iron was in high school when it was me and some friends trying to burn each other. So that's like totally cool. My first experience with a soldering iron was my parents had gotten me one because they saw that I was sort of interested in this kind of stuff. And I had this is going to date me a little bit. I had a Sega Game Gear, so like handheld video game thing. And I wanted to make my own kind of carrying case for it. And I had this plastic tackle box. And I used the soldering iron to actually burn holes, or slots rather, I guess, into the tackle box to make room for my Game Gear. And so I didn't actually properly solder with it. I just used it to melt plastic, which is a really bad thing to do with a soldering iron. Yeah, I learned that the hard way. Make baked goods. Dude, baked goods are the best. I like cooking, but I'm terrible at baking. What's your favorite thing? Although I can make a really good pie. I enjoy making pie. But what's your what kind of baked goods do you like to make? Alright. So while I'm here, I'm going to make a couple of new things to kind of keep track of all the stuff I have to hook up. So I need a NeoPixel. And I need a RX, a DMX underscore RX. DMX underscore TX. And a DMX underscore enable. Actually, I want to hear more about this whole high school soldering iron incident. Like, was it in a class that you guys had access to soldering irons? Or did, like, someone just have one at home? 6 buttons, NeoPixel, that. Am I forgetting anything? Yeah, hopefully not. Ooh, Best Bake is a batch of 4 dozen Earl Grey cupcakes with a lavender buttercream. 2 dozen were vegan, 2 dozen weren't. And that sounds like straight out of a Great British Baking Show. Like, that sounds really awesome. So, yeah, 2 dozen vegan, 2 dozen weren't. Yeah, although I found out recently, because I thought I was going crazy with Great British Baking Show, which I love to watch. I've watched all of them. But it was like, I was like, sometimes it's Great British Bake Off and then Great British Baking Show. And what was nuts is that in England, with the BBC, where it usually broadcasts, it's called the Great British Bake Off. But Pillsbury, which is an American company, they like threatened to sue them because like they have like a whole like Pillsbury Bake Off, and so they had to change it to Great British Baking Show, which was kind of insane. But lavender buttercream sounds really freaking good. So it sounds very nice and light. Is it like a cream cheese frosting? Is it a traditional frosting? Is it a glaze? What kind of I guess, it's a buttercream frosting. You told me that, so yeah. I'm stupid, but that's okay. 4 dozen. Man, I wish I had some cupcakes right now. That sounds delicious. So, technology class. What kind of technology class was it? Okay, I don't need these guys anymore. So for this, we're going to 25, 26. Let's do this. I'm going to make that one 4, 25, 26. We're going to do we'll figure it out. All right. That was 10th grade year. It's been a while, but we learned soldering, Photoshop, how to use a 3D printer, all that jazz. Well, that couldn't have been that long ago. Like, 3D printers haven't been out forever. So, that sounds like a really cool class. So, let's see. 10th grade. I'm trying to think about kind of what stage of life you might be in at this point then. Soldering, Photoshop, how to use 3D printer. That sounds like a really cool technology class. Sounds like you guys touched on just about everything. Cool. I should be able to program this now. Actually, I'm going to do rotary encoder A pin 25, 26, rotary encoder button pin 4. Let me see. Put -1. Okay. -1. Rotary encoder steps 4. How to use a 3D printer. Yeah. What kind of printers did you guys use? Do you remember? Have you used any since? see. I hope that didn't just break everything. We'll find out. The only downside about using these ESP32s is they do take a little while to program. Aha, cool, okay. So that works. Now, the question is, rotary button on click. I kind of don't care about that. 20 right now, so it's been out of high school for 3 years, 10 years ago. Well, maybe 4 longer. Okay, that's cool. So, are you going to college now? Or are you working, hanging out? So 21 is a cool age because you could be doing lots of different things. Rotary loop, rotary encoder, read rotary encoder. Boundary circle values. Set boundaries and if value should cycle or not. So I'm going to ditch this. Rotary set acceleration. Cool. No, a cube shape. Okay. Weirdly enough, I think I know which one you're talking about. I used to use some of those. Can't work, dropped out, so I can't go to college without a high school diploma. Oh, I gotcha. Okay. So, I'm sorry to hear about that. But, you're online learning about how to design PCBs, so you're still doing good stuff. So, can't go to, okay. I think what's most important is that you're doing stuff that is keeping you engaged with your mind, however that works. So everyone's a little bit different, and yeah. Click. I ditch that. So yeah, when I graduated high school, I didn't even go to college for a couple of years because I was still trying to figure out what it is that I wanted to do. So everyone's kind of got their own path that they take, and that is okay. Okay, I think I'm going to check to make sure that this works again. So what kinds of stuff do you like to do? So you have hobbies that you like to do, games you like to play, people you like to hang out with. Okay, so that's still working, which is good. Now we're going to figure out if we can do 2 of these. Encoder 2. And this is going to be on pin 27 and 32. Let's go on the great hunt for pins. 27 and 32. So I see 27. There. 32. Should be there. And actually, before I do that, I'm just going to double check to make sure that these work. Right now, I'm chilling. Mostly been crocheting and watching Twitch and YouTube. I bake for an organization every Thursday. Dude, that sounds awesome. Chilling is totally okay. Crocheting is lovely. So, I kind of crocheted a couple of times. I'm not terribly good at it, though. It is definitely a talent. And bake for an organization every Thursday. How awesome is that? So, is it like a nonprofit organization or church, homeless shelter, community organization? So that's cool. It's like You got peeps that you're helping out. You're learning to crochet still. Okay. Oh, okay. So this one works okay. Good. Yeah, so you're learning new skills? That sounds super awesome. It's one of the things that I like about being a college professor is like, I always have to teach my students new stuff, so I always have to be learning new things, which is great. I love learning new stuff. Alright. And for this last one, like I said, tonight, I'm definitely learning a lot of new stuff. I'm just figuring a lot of new things out. D4. That's like the challenge of that. And D33. 33's hanging over here. The organization is a mental health facility. Dude, how nice is that? I'm sure they really appreciate the cooking, especially if you're bringing them like awesome things like Earl Grey cupcakes with lavender buttercream frosting. So is that just something you came across or an opportunity that popped up? Do you know someone that works there? 33. So I volunteered at a mental health organization one time, or a facility. So, ooh, okay, I broke something. That's okay. This is why we touch this. Yeah, that's angry about that. Not happy about that 33 apparently. Let's disconnect that one. Nice. To a local library as a donation. They were put on display. What? That sounds super legit. It's the type of thing where, like, you know, they can like auction them off for, you know, help raise money for the organization. My mom makes quilts and spends a ton of time doing them, and auctions them off and then donates the proceeds to women's shelters, I think. So that is so cool that you're involved with your community. So I used to do a lot of community work, but when COVID hit, it got a lot harder to do that kind of stuff. So I haven't done it for a little bit. Alright, let me see if we can bring this thing back. D4 hasn't died yet. That one doesn't seem to be. I can go up. I can't really go down. Weird. I'm thinking I've got an issue. Let's double check. 33 says okay. 4 says it's okay. Okay, so I think I'm gonna kind of swap around my priorities here. I volunteered at the facility and I brought up baking, and they asked if they brought me ingredients so I could bake my course. That is so cool. Wow. So what kinds of things do you bake for them? So obviously you did cupcakes for the library. So what kinds of things do you bake for the mental health facility? Alright, so we're redoing this whole nonsense here. So in fact, I'm going to go 4. Oh, I suppose I can use 2, can I? lemon cookie truffles. I don't know what that is. I want to look it up, but I love anything with lemon in it. So lemon cookie truffles. Oh my goodness. Those look amazing. Wow. How do you kind of decide what to make? Do you just kind of look for online recipes, or is there someone you learn from, or you got a cookbook? Because that just looks freaking ridiculously good. Don't need that. There we go. Alright, we're gonna go 18 and 19. We're gonna try. Alright. 18, 19. Oh, Zane, you goofball. Of course it couldn't read that. Alright. I made a boo-boo. Cool. Okay. And then we're going to do 21, 22. 22. Sugar cookies, crush them, and use marshmallow cream as a combining agent. Let those chill and dip them in white chocolate. Holy crap. Sugar cookies, crush them up. Sugar cookies are so good. Marshmallow cream as combining agent. Let those chill and dip them in white chocolate. Wow. So for the lemon cookie truffles, what part of that then is like the lemon? Do you do like a lemon drizzle on top of it or something like that? Just look up a recipe from the internet. Wow. That's so good. 23, 25. Okay, I think that one's okay. Is that it? 18, 19. 21, 22. Lemon extract, yes. Oh, yeah, lemon extract is the bomb. Like I said, anything lemon, I'm all about it. I just love the citrusy flavor. Okay, so that's doing a thing now, which is good. Man, the last one before I can do this big test. 23, 25. Oh, God. 22, 23, 25, 26. Goofed again. So we're going to go to 26, there you are. About a tablespoon per 18 good-sized truffles. Yeah, that sounds really, really good. I'm very excited about that. Oh, okay. So that works, and then I just need to test this previous one that I screwed up. Hopefully we'll be back on the next 22, 23. Yeah, lemon extract is really good. Like peppermint extract, orange extract, lots of citrusy things is good. And you're working good. Okay. Now, I'm ready to try this again. I guess I need to walk my way through this. So I just ended at 26. So 7. I think NeoPixel is going to go to 4. 32. 33. Ooh, don't do that. 32. 33. 35, 36. Yeah, I just don't see. 34, yeah. I see 35. That's volts. It's 34. Okay. I don't think I've used 13 yet. Let's go with 13, 14, 15. Okay, cool. All right, man, complicated build tonight. Okay, so we're going 18 and 19. That is not 18. All right, rotary encoder 2 is going to be 22 and 23. Okay, setup. So we're going to take this whole thing and make that do this. Read encoder ISR. I don't know what that does. Dot setup read encoder ISR 2. Cool. Rotary loop. Alright, this is where things are getting tricky. Can we make 2 of these work at the same time? Nobody knows. But hopefully, otherwise my entire project is going to kind of come to a standstill here. Isn't that it? That does a thing. That does a thing. Value 1, value 2. Do I hear 3? And that's 25, 26. 3, value 3, that's a 4. Okay. 3, 3. 3, 3. Alright, big moment here. So, my question would be is if you could work any job that you wanted to, what kind of job would you want to work? Okay, so that's value 1 going up and down. That's value 2 going up and down. Yes! Value 3 going up and down. Yes! I did a thing that actually halfway worked. And now I can actually get back to work. Bakery and nursing home. I think that kind of makes good sense. I mean, you've got the whole baking thing, and then working with people who need help. Yeah, that seems like that would be a really good way to go. Got so many more of these pins to add. So we're going to do rotary encoder 1. Rotary encoder 1A. Rotary encoder 1B. And then we'll copy both of these. Can I copy both of those? 2A. 2B. 3A. 3. That is a lot of stuff to hook up. Let's go to technology. Did try Python coding. Okay. Python is awesome. I have taught Python before. It's a really good beginning programming language, I think, because it really enforces a lot of strict kind of like formatting rules. And like you can kind of see with mine, like I always try to like, you know, format my code very nicely and cleanly, although people may take exception with that. And so Python is super legit because it really helps people learn quickly. So that is quite lovely that that's something that you've done. Was that part of your technology class, or was that a different experience? Right. So 1819 for RE1. 18. 19. RE1. Okay. 22, 23. Where are you? There you are. 22, 23, 25, 26. Just trying a new hobby. I go through hobbies like I go through baking supplies very quick. Yeah, no, it's good to try lots of different things. Were you using like an online tutorial then to try to learn Python? And were you trying to learn on a Mac or a PC? Just out of curiosity. be learning HTML, PC, and it was online learning. Cool. HTML, Python, and Kotlin? I don't know if I know Kotlin. What is Kotlin? Programming language. Oh, cross-platforms, statically typed, general purpose programming with type interface. Java. Oh, that sounds really cool. So, okay. Interesting. So I use a program called Processing, which is also kind of Java-based, and I really like it a lot. So Kotlin sounds maybe it's kind of like that. So I like to make a lot of kind of artistically inspired programming, or programs rather, and processing is really good for that. 21. So multi-learning, HTML, Python, Kotlin. That sounds like a lot all at the same time. Good for you. Yeah, my very first programming language was BASIC, and that was the programming language. It was called BASIC, but it was good. It taught me a lot, and got me interested in programming. But yeah, I don't use that anymore because it's just way too old for the type of stuff that I do now. B2 goes to 32. This is going to be one heck of a circuit. Got burnt out by learning 3 types at the same time. Yeah, that can get really super confusing. I'm not surprised. That is a heroic effort to learn that much. Especially like HTML is like I use HTML a lot, but it's not my favorite. B4 goes to 13, so B4 goes to 13. Ground, you're gonna have to get out of the way. There we go. 13, 14, and 15. So B5 goes to 14. But programming is super useful though. Like there's not a day that goes by that I'm not, that I regret learning programming. That I don't regret learning programming. I don't know how to speak. I'm very glad that I know how to program because it is super useful. Neo is going to go to 4. IO4. Ooh-wee. Okay, back to these guys. I think what I learned was that I'm going to drag these down here. So these are the rotary encoders. So these are the little spinning knobs that'll let you set volume and light intensities and all sorts of cool stuff. Change the mode if you want. I think what I learned here was that this is VCC. This is the voltage that comes into the little circuit dude, I hope. Yeah, it's probably okay. I guess I'm going to try one of these guys just to make sure. Buddy. Let's try this. Yeah, okay, cool. That does work. All right, which means that is correct. I almost forgot it wasn't 3. Oh my gosh, CSS? You're insane. Yeah, the web design stuff is really, really cool, but CSS is the bane of my existence. I did a lot of web design professionally a while ago. Now, one thing that you might look at if you're like interested. So that's all front end web development. So that's all the stuff that like people get to see. You could also look at back end development, and back end development is really cool because it is kind of more just traditional programming. I hate that. But you don't get all the CSS and HTML weirdness. And so my favorite back-end programming language is something called PHP. It is super awesome. And it's kind of similar to something like kind of Python. Let's see, I think I'll just do this. So if you're looking to get back into that and kind of want to go back to some kind of programming roots, you might look into PHP if you wanted to do the whole web design thing, which is like you can do like a work from home, which is kind of cool. Like I've got lots of my kind of former students that do a lot of remote design, which is cool. These guys up, make sure they're attached. And there are my rotary encoders. Yeah, but I cannot imagine learning all of those languages at the same time. That's so tricky. Good on you for trying. I don't blame you for kind of burning out on it though. Man. Okay. Struggle continues. For all these stuff. I'm about to add a lot more with these neopixels. Reorganization here. I like to make things look nice and organized because it just makes for better design. You can catch mistakes easier. Alright, I think it was more of a tried out hobby and now I'm done with it for a while. Yeah. No complaints there. So it's good just to try stuff out and see how it works. Alright, now time for neopixels. So I need 4 per button. So that's 24 there. So I've got 6 buttons and 8 per rotary, so that's 24. So I need 48 neopixels. Dear heavens. This is going to be insane. So neopixels are little smart LEDs. Let's see, how do I want to organize these? So if I drop one there and one there, D out, D in, D out, D in. Yeah, that'll work. But I gotta be thoughtful about how I do this. I got so many of these I have to cram in here. I need 48 of these. I got 4, so I need 12 rows of those. Alright, we're going to try Well, it sounds like you tried a lot of different things, which is super cool. VCC. Ground. It's kind of ugly. Alright, so what we're doing right now is we're hooking all these LEDs up together. And there are going to be a ton of them. I do this. I need 12 columns of these. Excuse me. Bugger. There we go. I need to do this. That's kind of nice though. It brings that with me. Okay. So they all connect. Clean that up in a little bit. That's 5 times 4 is 20. Yeah, I'm going off the page here. Oops, not what I wanted to do. Alright, let's try. I'm going to move these elsewhere. I'm going to arrange them like this. So that's 8. I did 12. I just need 4 columns. Remember attaching them. I think if I remember correctly, I can't just copy and paste. Because it does everything backward then. Such as life. Weird. Why did that get offset so much? Yeah, maybe because I didn't attach them as neatly as they should have been. We're going to attach those two strands together. And the question is, if I do that, does it work? Nope, still reverses them. So annoying. I wish it didn't do that. So what do you think burned you up most about programming? Too much information at once. Yeah. I can see that. Starting to wonder if my ambition for this circuit is a bit too much. This is a lot of components. I'm going to have to cut back on the number of LEDs for this. That's not fun. I like stuff that lights up. Whoo-wee. Width 1500, 1700. Yeah, looks like 1700 is the answer. course. All right, now we are to a really exciting time. And that exciting time is when we get to actually turn this circuit into a circuit board. Oh my, why are you not connected, ground? You're supposed to be connected. Wow. This is bonkers. Alright, let's save that. And here we go. Convert schematic to PCB. Look at all those components that we have to figure out. And the really fun thing about PCB design, all these lines going all over the place to these components, you have to untangle them and turn them into what are called little copper traces, which are just little copper wires. Alright, so let's make sure we are in millimeters. Let's make our grid size 10. And I want to do rounded corners on this. Let's do grid size. So I said I'm going to do 120 by 150. So I'm going to top silk layer. Oops. 10. Something like, so I'm going to do a thing that is 150, that's 120. These are kind of guidelines for the outline of the circuit board that I want to make. Actually, give it to you. Okay, so if I go to my board outline, now what I'm going to do is I'm going to kind of go over there, over there, over there. Is that too rounded? It's going to be too rounded. I don't want to make it look like a cartoon speech bubble. Okay. And then go there, there, there. Combine there, there. I always forget. This tool's kind of broken. And combine, click off. There, there, there. Combine, click off. There, there, there. Combine, click off. Okay, so if I come up to my these, I can kind of get rid of these guys. That's going to be the outline of the board. So sometimes circuit boards are kind of square like this. No, I don't like squares. I like them when they have nice rounded edges. One thing I want to remember is I am going to do some mounting holes. Mounting holes here. And how big are those? I'm going to make them 3 millimeters. Cool. Save that. Now, we can kind of look to see what it sort of is going to look like. This is going to take forever. So those are all the components. This is the PCB. We've got to put all of these components on this PCB and make it all fit. Doesn't seem like it's tough, but looks can be deceiving. Okay, so I want to take a look at these buttons first. Three, 5, 6. I don't know why these are called what they're called, but it's whatever. At the end of the day, I guess it doesn't really matter. Just that they all fit the thing. And that they're like evenly spaced. This is where you get to be a little kind of zen. So is that too spaced out? So, because I think the plan then is I'm going to just kind of spacing, because these are going to kind of be the spots for my potentiometers. Oh, that's weird. So I'm just doing some rough layout here. Oh, hey, we have another visitor. Yeah, 48 neopixels, by the way. So I've got some ambition. So M. Kelly, I don't know when you joined, but yeah, this is my PCB design for this one. I think it's going to have the highest part count of pretty much any PCB that I've ever designed. So fun. Let's go snap size of 5. Let's see if I can kind of center this guy up a little bit better. Yeah, not really. I hate that. All right. And snap size of 1. Oh yeah, those neopixels. Yeah, I'm very excited about those. The real question is, I guess I'm probably gonna let them use the pick and place to build this. If I'm nice, if I'm feeling nice. All right, just trying to get a good sense for. The real question is, does that leave enough space? Because I'm kind of trying to bias toward the side here so all the other components can fit along this kind of column here without making it look too wonky. I think I might budge everything over just to kind of slot it in here a little bit more nicely. bumping 5. Ooh, that's probably too close. Yeah, got all these rotary encoders. Low key. Their center kind of sucks. I probably should go fix that, but hand placing. I mean, my first pop art PCB had like 120 LEDs, and I hand placed every single one of them. But then again, I am a crazy person, so. The thing that is, I'm actually kind of worried about with hand placing the NeoPixels, though, is I have them kind of rotated at really precise angles, and I have noticed sometimes the pick and place can get wonky about angles sometimes, and so, oh, yeah, I think I'm gonna like this. Orientation. No, I need to orient like this way because we're gonna have NeoPixels around these guys. Okay. And the question is just how do I want that to be in here? Probably like this, because I'll do a whole keep out. Yeah, that's right. I remember that. So yeah, so that's kind of the problem that I'm up against, actually. I'll throw you down there. Angle right, put off center. Ooh, did you do kind of crappy initial calibration? I can't imagine that you did. That sounds like an initial calibration issue, but could just be crappy. Oh, Zane, you idiot. You've forgotten so much. I have to go back. I have more components to add to this. I forgot all my DMX circuitry. So, dig that up. Yeah. Oof. I also feel like I screwed up some of your guys' things. So I've got to add this whole circuit in here. I completely forgot all the DMX circuitry. So let's save you up. Here I thought I had actual space. Huh, I lied. I felt really bad for you guys. I think y'all... Was that an all-nighter for you guys when you were making those LED keychains? Because I think at some point I was like, yeah, I gotta go, guys. Because I was tired. Okay, ooh, back to yes. We got to do a little bit of research here. So let's do DMX serial DSP 32. circuit that I designed. Let's try it again. DMX. Yeah, so sick. I thought I was going to hurt someone else and ended up falling asleep on the concrete. Rachel, hey buddy, you can. Jeez. I did not know that part. Wow. That is, that sounds very rough. There we go. Alright, let's go shopping for parts. Why on the concrete? Did we not have the foofs in the lab back then? You go away. XLR connector. It looks so tiny, but it's actually quite big. It was cool when I was here. Well, yeah, I'll explain why you're out there. I need to go shopping for a Max 485. RS-45 ICs, that's what I want. Ooh, that's an interesting question. Do I want... I assume I want surface mount. There's no way those can be that cheap. These things are like $5 a piece. Oh, they have... Well, let's go in stock. I would like ones that I can buy, please. Let's look at the data sheet for this. Yeah. That is what I need, I believe. All of these data sheets combined, I should be able to, yeah, it looks like it's wired the same. So, cool. Let's see if it has a rating. Ooh, it may not. I really like it if it did, though. I also need a resistor of some variety. Anybody remember what resistor, value resistor that is? I can find it out in about 3 seconds. $120 ohm resistor. And I'm guessing I don't have one of those in here already. What a stroke. Fabrication, bill of materials. I do not have a 120 ohm resistor for 1.2K. That's a lot more than I need. Okay. Well, let's go shopping. Let's go to resistors. Let's go to an 0603. Let's go to 820 ohm. 120 ohms, there we go. In stock. Apply. I like these Uniroyals. I've used them a lot. Basic, they even have them in stock. Very chic. Sketches. Not sure if you want to go through the trouble, but if you register a new Sketchers account on your web browser, download the Sketchers app after registering and answer some quick survey questions about shoes. Sketchers, products, sunglasses, and socks. Thanks, hey, cool, thanks. I appreciate the follow. So, and the chat. So hopefully you've been enjoying the what I loosely call entertainment. So, yeah, I've only been going in 2.5 hours and still probably have 3 more hours to go. So, this is a big one. It's going to be a very long YouTube video. I apologize for anyone who's watching this later on. Whew. Okay. So, I need to figure out 3-pin DMX. Okay. So according to this, okay, pin 3 is data plus. Cool. And then I figure out, is this a male connector or a female connector? I believe this is a female connector. Let's just double check that. Yeah, it's a female connector. So according to this, on a female connector, pin 2 is data minus. And then pin 1 is ground. Oh, okay, cool. I totally get that you need to head out. So I stream between once a week and 3 times a week. So it all just depends on kind of what projects I have going on. I should have a lot of PCBs, physical PCBs coming in next week, so more of the streams are going to be me soldering stuff together. My link to the Discord should be on my on my social links underneath there. Yeah. So I always announce on Discord before I actually go on stream, but I don't have kind of a regular schedule. So if you want to jump on the Discord, you can always get a message or follow and you'll get an update. So, but thanks for joining. Hopefully you get some good sleep and hopefully I see you again later on. Good chatting with you. And good luck with all the baking. All right. BCC. CC. Excellent. This combines, yeah, data minus and plus. So the real question here, with as insane as this circuit is turning out to be, is this going to be too much for students to do? And that is a difficult question. This is D plus is here. Excuse me. VCC and ground. Yes. Oh, look at that. Come back. These will go to the enable pin. Is receiver output. Right. So that is the DMX receiver. No, DO is the output. DI is the input. Give a little more space to breathe. Holy cow. It's just so much. Alright, let's update. Let's hope that it has a 3D model. Yay, it does. here somewhere. He's big. Different idea. Yeah, so we'll have it coming out the side. That's kind of cool. I like that. I'm just going to throw that anywhere at the moment. have an LED for? I do have an LED for. Where is LED for? So 3, 4, 5, 6, 7, 8, 9, 10. So 10, 5. There you are. I'm actually going to grab this guy. Do that. Kind of move it there for now. Because yeah, there we go. Now for my next trick. Is how to find all the angles and positions for these. So I think we're going to have another one here. So we're going to bring these over here. And we're going to set the values. So 0, 17.5. Good. Math is fun. 6.697. 16.168. No, actually, no. 12.374. 12.374. And rotation is 45 degrees. The negative persuasion. Good. Alright, next. 17.50, negative 20. This is how I want this to film. Which is annoying. So let's go in reverse order. Okay. So I'm going to say that's going to be negative 45. So now when they come across, yeah, they'll just loop like that. Oh, come on. Negative 17.5, rotation is 90. Cool. Alright, now we're back on track. Okay. So that one over here. So X location is going to be negative 12.374. Y location is negative 12.374. Rotation is 135. 7. X is going to be 12.374. Rotation is going to be 15 degrees. Now you can see how nicely they rotate around. So this is going to be for the rotary potentiometer where you're like boop, 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 and it will light up, hopefully. Get this as close as possible. I think that's it. Yes, that is what I want. Okay. Just doing a sanity check. Alright, so I left off at 10. Let's go grab 11 and up. So 5, 11, 12, 13, 14, 15. There we go. Oh god, yeah, I hate the offset labels. Yeah, it started on 3, which screws up all the numbering, so I'll have to go back and re-silk screen it all, which will be fun. Yeah, good attention to detail though. I want to be there. But I like my little geometry chart here. That helps out a lot. Okay. I made this when I did the first smartwatch. 0, 17.5. .374, rotation 25. Negative 17.5, 0, 90. Negative for ID. Rotation 135. 0, 12.374. Sorry, you're supposed to be positive. You're supposed to be negative. You're supposed to be 225 degrees. 17.50. 12.374, and 315 degrees. Great. Now let's transport this one up to its rightful location. Delete the stacks of LEDs and just copy paste your ring. It's already done. Ooh, I bet if you delete the stacks of LEDs and just copy paste your ring that's already done, it'll number them again in order. Yeah, the problem is then my schematic may be off. Like, I have trouble, like, so you can sync your schematic to your PCB, but you can't sync your PCB to your schematic. So I would be worried about losing synchronicity. When it comes time to, oh my gosh, those LEDs are right on top of each other. I'll have to play with that. Update PCB and already drawn the nets. Yeah, I don't know. I'm nervous this far into the game about trying that because I've had things where like the nets get confused and I've had to like start over circuits. So I like your idea, but I'm very nervous about it. Mostly just because I just need to try it in a small circuit. So let's see, that's 7, so where's 26? There it is. Because truth be told, I'm going to relabel all this crap anyway. Okay, you guys can come hang out here. But yeah, I'll have to try your suggestion on a simple one. Because that would be brilliant if that worked. Okay, here. Start to get these memorized though. 17, 0, 17.5. Negative 12.374. 12.374. 45. I don't even have to look at my chart anymore. Negative 17.5. 0. 30. Negative 12.374. Negative 12.374. And 135 degrees. 0. Negative 17.5. 180 degrees. 12.374. Negative 12.374. And this is 225 degrees. 17.5, 0, 270 degrees. 12.374. 12.374. And 315 degrees. Look how quick that was. Begotten file labels. Maybe test first on a duplicate, like duplicate the project test there in case it breaks. The jet lag is real. I am also not looking at it in as often as I probably should, so I apologize for that. At some point I should just have like just the open Discord open and pipe that audio so like people can just like voice chat while I'm doing this. Oh, what? Are you not gonna like line up perfectly for me? Lame. Oh, the other ones did nicely. Why are you so weird? Oh, those LEDs are right on the edge, aren't they? There's going to be no room for traces. Two-minute delay, holy crap, that is atrocious. Let's see, so you're enabled. Das Boot. I feel like you guys are going to want to be on opposite sides. Wowzers. Alright, next group. Forgot where I left off, so I see a 30, I see a 27. Guys are in groups of 4. So that's one group. You, another group. So 35. So you're all together. Hanging out. These guys. Our last group is here. It's a ragtag group of LEDs if I've ever seen one. These are going to come cascading down here. So I guess it makes sense to kind of maybe snake up and around. So here's the real fun. T-shirt. Yeah, it's doing these really repetitive tasks that feel gross. It's easy for things to go haywire, but so far this looks like it's going okay. I just have a feeling like the students are going to kill me when I make them make this. But it's so zen. I'm having a good time. Cause we're having a good time. I can't wait to get copyright struck for humming a few bars of that. Better. Oof. All right, LEDs have been placed. Looking fancy. Now time for all the stuff. Zoinks. Alright, how about a power switch to start off with? some charging stuff. So U1 R3. R1, R2, and 2 LEDs. C1 and C3. Okay, so those guys are kind of going to hang out together. Next, protection. So U2, R4, 5. U2, R4, 5. Ooh, easy tiger. And C2. So you guys are going to hang out together. Q1, which kind of its own deal. U7 is with C4 and 5. U7, C4 and 5. Good. R13 and 14. You guys are kind of over by yourselves for voltage sensing. And that leaves R10, 11, 12. R15 hanging out there with this dude. Because I know several of these are going to be going to the buttons. 7, 8, 9, 10, 11, 12. So R6 go to. To the enable button. Cool. Alright, let's turn on some nets. Let's turn off VCC and G and D. Start shoving all this stuff. 2.5 hours with this guy. Alright, let's look at this 3D file. There she be. That's a lot of parts. That's a lot of parts. Hoo-wee. A lot of things to connect. Well, time like the present, I guess. I'm gonna try to be like really methodical about this. One of these days I'm going to rewire NeoPixels so that you can arrange them clockwise and have the pins go nicely together. Only 120 nets. Yeah. I will be saving very frequently for this one. Hey, look at that. 75 out of 120. Progress. central. Very much like to avoid islands if I could. That is an ugly trace. Just a lot more buttons and grounds in VCC. Now the tricky parts. Ground and VCC. Let's save this up. Alright, we'll start cruise. See if I missed any. Sweet, I did not miss any. Now we're gonna do grounds. There's gonna be a heck of a lot more of those to do. Delete that for now. ground planes. Are good. Let's do ACC planes. Yes. Nice. All right. Ooh, let's do some bottom silk. All right. Let's see how we did. Ooh, I've been sitting in this chair for a long time. Wow. She's beautiful. Look at that. Alright, should we see what the damage is for cost? I'm guessing $14. Oh no. $43? Oh, that's not gonna work. Oh no. Why so much? I've got to figure out how to do this on 2 layers. Oh no. That is 12, 1, 2, 3, 4.5 hours. Just gone. Oh no. I'm gonna have to completely redesign that. It's like, that's so expensive. I think the size, it can't get any smaller than that. Why such a big jump? Oh no. I thought I was in the clear. Alright, I think I'm gonna have to end the stream there and go get some sleep and think on this. Because that is so pricey. Unless there's another fabricator out there that could do it cheaper. Let's see what a PCB weight does. Dimensions 150 by 130 by 5 by 4 layers. $115. No. To be fair, I think it's 120, but oh my gosh, I feel sick. That is an absolute disaster. Well, sorry folks. That is gonna take some rethinking then. Yeah. Because that is just too darn expensive. Look at what would it have been if it was just 2 layers? Let's see. Oh, really? I could have done it here. We're at 150, 120, right? 150, 120. 2 layers. $11. Lesson learned. $43. Such a jump. What is it if I do 100 by 100, 4 layer? 8. The answer is 8. The instant you jump over that 100mm line, there's just no mercy. Alright, to be continued. Wow, just completely blown away by that. Look at all those parts. Alrighty, sorry folks, we'll catch it up tomorrow maybe.